Assalamualaikum warahmatullahi wabarakatuh. Hello, my name is Muhammad Abdul Haq. I'm from Computer Engineering Politeknik Elektronika Negeri Surabaya. This is my final project's demo and the title is Peningkatan Kecepatan Proses Deteksi Bola dan Deteksi Obstacle pada Robot Erso menggunakan Omnidirectional Vision berbasis Robot Operating System (ROS). And the first advisor is Mr. Iwan, and the second advisor is Mr. Bima. Before we start further in this video, I will present about the introduction. This research deliver a novel approach for improving the computation speed of the ball detection and obstacle detection process in our robot. The speed condition of obstacle detection and ball detection in our robot still have a slow processing speed. This condition makes the robot not real-time and the robot's movement is hampered. To build a good world model, things to note are obstacle information and the real-time ball detection. The focus of this research is to increase the speed of process of the ball and obstacle detection. To increase the speed of the process, it is necessary to optimize the use of the OpenCV library, Boost library, and implementing robot operating system to divide the process into several small processes, so that the work can be optimally divided into threads that have been created. Then, minimize the use of too many frames. This information will be sent to the base station and also for obstacle avoidance process. And this is the tools and environment for my research. We can see I use the laptop with Core i5 and with 8 GB RAM, and I also use an omnidirectional camera for the sensor, and I also use the field. And this is the robot. I take the robot number 4, and the system is running in Linux Ubuntu 16, and the ROS version is Kinetic. So this is the flowchart of my program. The first is input. The robot input is an omnidirectional camera, so the camera will take the frame of the field and the ball and the obstacle and then send into image publisher. After image publisher, it's divided to two programs. The first is ball detection and the second is obstacle detection. There are thresholding process, there are color extraction, the segmentation, and then ball detection. And after detect, I must calculate the distance of the real position of ball and obstacle with adding the odometry, and then I send into the base station, and the output is x, y, and theta of ball and obstacle. And before I go to the research, I target maximal is 24 millisecond for ball and 33 millisecond for obstacle. Okay, this is the graphic of robot operating system in the robot. So we can see this is the Omni publisher, this is the input, and then send into camera Omni and divide into two. There are Omni ball and Omni obstacle, and then add with odometry and then send into the base station. So the vision is in here in the bottom. Okay, let me go to the video. I have prepared the video. This is a final project video. So before I explaining about the system, this is the first condition of ERSO. So we can see that process speed in Omni obstacle is 67 millisecond, and then in pole detection it takes speed 42 millisecond. So this is too slow for real-time robot. And then this video proves that in my research is not affected in pole detection. So after I implement the system, the pole detection still good. You can see in this video the pole detection is still good. And then in obstacle detection, this video proves that if I implement with my research, the detection of obstacle is still good. You can see the robot can still detect the obstacle well. Okay, still can detect many obstacles. And this is the final result. In this final result, I run without showing the frame, because showing the frames makes the program too slow. And this is the last result. So we got 18 process speed in the pole detection, and then in obstacle detection I got 24 millisecond. After we saw the video, this is the graphic of increased speed progress. There are rows, it takes 5 millisecond, and implementing region of interest with maximum is take 9 millisecond. With optimizing the frame, it takes around 11 millisecond. And then in obstacle detection, this is the graphic. In rows take around 3 millisecond, and region of interest is 11 millisecond. And I implementing binary inverse in inverting the color of obstacle. It takes around 10 or 11 millisecond. And the higher is optimizing the frame. It takes around 17 millisecond or 18 maybe. And alhamdulillah, I got 2 publications in this research. So I got 2 publications. The first is the paper entitled "The Base Station Application of Aerosol Team for Communication Between Robots." So in this paper, I describe about the last step of my final project. So there are base stations, so the communication between robots, I explain all in this paper, and how robot is communicating. And this paper accepted in 2020 27 International Conference on Telecommunication or ICT. And the last is in IJEX, International Journal of Electrical Engineering and Computer Science, with quartile 3. The type is journal, and the title is Improving the Speed of Pole Detection Process and Obstacle Detection Process in Aerosol Robot using Omnidirectional Vision based on Robot Operating System or ROS. And this 2 publication, the paper and journal, is accepted. Take the online conference because there are pandemic, so I cannot to attend, or because the event is not held in offline, so I present online. And thanks for watching. This is my final project video demo. Thank you. Wassalamualaikum warahmatullahi wabarakatuh.